This video covers how to explore numeric data in R, and I'll also cover something that trips people up often when they're dealing with numeric data in R. So when a client first gives you data, it's a good idea to explore the data, and there are a few reasons for that. You want to better understand the data. You want to gather questions for the client because it's not always going to be clear exactly what all the data mean, and if you see any potential issues, that's another thing that is very common, that clients have errors in their data and you don't know why that is, or it might not even be an error, but you need to find out. So you need to discuss that with the client. And because your data are in a table format, you need to explore the columns and you need to explore the rows. The columns is what this video is about, and in particular it's about numeric columns that contain numeric data. Now for those of you that want to replicate what I'm doing, I'm using R version 4.1.2. If you don't know why that's important, take a look at the video that I created called Understanding R Packages, and I'll post a link with the code that I'm using in this video in the description of this video. So we're going to start out by reading a data file into R. In this case, it's a CSV, so we're going to use the read CSV function inside the utils package. And then we're going to assign the contents of that file into this object called the customer A data, and that's just what I want to call it. So I'll highlight this line and then I'll hit run. And you'll notice that it's in R's memory now because it pops up here in this environment tab. And we can take a look at it by clicking on it. It'll show us this little preview. You can't edit the data, but it shows us its values for some of the records here. So we can see that it looks like it did in the CSV, nothing crazy happening here, so that looks good. Now here's the first important tip. You want to make sure that you're paying attention to the data type of the object that you just read in. So when you read in some data, R is going to store it as a particular type of object, a data type. And so this customer A data is being represented in R as a particular type of data. And so let's take a look at that. We can type in str, which is a function to look at what's called the structure of an object. And so we want to check that out for this object that we just created. And then we'll hit enter, and it says it's a data.frame. A data frame is one of the data types. It's a very common data type in R. Basically, it's a table. It's the way that R stores a lot of files that you read in, a lot of data files. So when you read in an SPSS file with some function, or you read in a CSV in this case, lots of times it defaults to storing it as a data frame. And that's important because there are certain characteristics of a data frame. For example, here's an important one. You can refer to certain columns in that data frame. So here's the object. If I want to look at one of these columns and I want to like print it out here or reference that, then I can click a $sign and it'll give me a list of all of the columns in that. So that's specific to data frames here. So now I can say, okay, well, like income, and then I can just hit enter and it'll show me all the values for that column income in the data frame customer A data. Another important reason that you want to pay attention to the fact that it's a data frame is there are certain functions that you'll be using that assume that the thing you're giving it is a data frame, and it won't work if you don't give it a data frame. Here's an analogy that might help you understand the role of a data type, so like a data frame and functions expecting data frames. So let's imagine, for example, you had clippers, and clippers were a function. Its function was to cut hair. And it's expecting a certain type of object. And the type of object you would expect for clippers is human hair, because that's what it was designed to cut. But instead, if you gave it like, sheep's hair, which they get like, their wool sheared, it wouldn't work and it would most likely break. It's the same sort of concept. The people who wrote functions in R are expecting very particular things to be received by that function, and it is executing a certain sequence of steps, all with the assumption that it started out with the right type of input. And if you don't give it that right type of input, it will break and it'll throw out an error. Hopefully it's a helpful error, but sometimes it might not be. But this is why it's important when you're working with data files that you're reading into R to make sure that it's being read in as a data frame, because most of the time that's what you want it to be in R. Here's tip number 2. When you read in a data file into R and it's hopefully being represented as a data frame, you want to check each column and see what type the column is. So in this case, ID is an integer. That's what int stands for. Name was read in as a character column, so it's just text in this column. Age was read in as a character column. Now that's kind of weird because if we look at this, we see that it says 28, 24, 23, 45, but they're in quotes, which indicates that it's a character. And you might be confused about that. If you got this data from a client and you were expecting age to be numeric, you might be wondering why this is happening. So you can click on the file and explore that quick. And if we see here, it looks like, yeah, all of these were being written as numbers with the intention of representing a number. But then somebody typed in here 72 as text. And so when something like this happens in R, when it reads in the file, if it comes across any text in a column, it will assume that column is text, because that's the safest assumption for R to make without having to exclude any data. It couldn't store this as numeric because then it would have to delete any text you had in there. And so R will just accept everything in there, and if there's any text in there, it'll treat it as text. This comes up a lot with clients. Sometimes they're not, they don't have a way of capturing the data that's doing this quality control stuff. So sometimes people can type in text in a column that's supposed to be numeric, and because of that, you get weird stuff like this. So it's important that you clean these data and get them back to numeric before you can actually perform any analysis, because I can't calculate an average of text. And so that's an important thing to pay attention to. In contrast, you can see that credit.score here is an integer. So that is a numeric column. And we can see here too that these were all numbers. So that's a very important thing to pay attention to. If you get an error when you're trying to calculate an average of something, it'll indicate, that it's a string or something like that. But this is why, because you were expecting it to be numeric, but it wasn't, because there's some text in that column. So you need to clean that up in advance. And I'll be creating another video on how to clean up numeric data. So now let's fast forward. Let's say you've cleaned all of your columns. You know that they're in the state that you want them to be for your analysis. And now you want to start exploring your numeric columns. So in this case, the only numeric columns that we have that are truly numeric is credit score. We have ID, but that's just an ID column, so that's not really meaningful here. So we'll go ahead and analyze this fake credit score data. And there are a few functions that are really helpful in R to analyze numeric data. So one of those functions is the mean function in the base package. So I'll say base. In fact, I'll do this in the code here so we have the copy. So I'll say base : and then I want the mean function. And so because we want the credit score column inside the customer A data frame, I'll use that feature that I talked about before. Customer A data is the data frame and then $sign to indicate which column, and I'll go down to credit score, and then I'll calculate the mean. And you'll notice that we'll get an error here. So first I'll highlight this and then I'll run it. And then it says NA. So it's not applicable. And you might be wondering why that would say that. Well, in this column, I have some missing data, and you can't calculate an average or a sum or anything else if you have missing data, because the missing value doesn't represent anything. And so you can't consider that while you're doing the analysis. So you have to do something about that. And there is an argument that you can use in this mean function. And so I'll say comma, because we already have the column here. And then next to that, I'll say na.rm equals true, which means remove the missing values when you're calculating this mean. So now I'll highlight that and then click run. And then that is the mean, or the average of this credit score. Another helpful one, and I'll just copy and paste that below, is median, and that is actually in the stats column, or stats package. And the base package and stats package, they come with R, base R, in particular this version 4.1.2. They come in other versions also, but so I'm going to highlight this here and then run that, and you see that the median is 559. You can also look at the minimum, the maximum, and then let me see, I think the minimum is in the base package. I'll highlight that and run that. Yep. And then the maximum is in the base package also. Max. So I'll run that also. So we see that the minimum is 303. The maximum is 796. And then let's look at the standard deviation also, which is in the stats package, I believe. So I'll say SD for standard deviation. And then again, I'll say NA dot remove, because we can't calculate any of these statistics if we don't take care of the missing value or decide what to do with the missing value. And we'll run that. So the standard deviation is 140.55. So, I mean, there are other things we could calculate for this also, but one of the things that's particularly helpful is to use this function called summary, which is in the base package. And summary provides you with several statistics off the bat. And actually, I don't believe you need to specify what you do with missing values, because I think it ignores those. Or it'll actually show you that they're missing, how many missing values you have, and it'll calculate the statistics without that. And so you can see that when you use the summary function, it'll give you the minimum, it'll give you the maximum, it'll give you the mean, it'll give you the median, and it'll give you a few other stats. It'll give you the first quartile, and it'll give you the third quartile. And then it shows you how many missing values you have. So the summary is a very nice one. Another thing that you may want to do is to look at a histogram of this variable, of this numeric variable. So I'll do base, colon, and then that function is called, you know what? That's in a different package, geometry, colon, hist. Oh, no, wait, graphics. Graphics hist. Now, I know the names of some of these packages because I've been using R for a really long time. This is just one of those things you'll get used to, and as you discover more packages, you'll get used to that. But these are all packages that come with the newest versions of R. So you'll notice I hadn't had to install any other packages here or use the library function to load the packages. And if you don't know what loading packages means, please take a look at the Understanding R Packages video. So this function is hist for histogram in the graphics package. And so we will put in that column, credit.score, in the customer A data frame. And then we'll highlight that and we'll run that, and that'll show us a histogram here so we can look at this distribution. So a very quick way to create a histogram of the credit score, and where it'll show you the frequencies of these credit scores in these different bins. So running these different functions are a good way, or is a good way, of looking at your data to see if there are any anomalies, problems that you need to go back to your client and ask about. I like to go through all of the columns, look at the rows, write down all of the questions that I have so I can go to the client one time with my questions, and then feel confident that if I get the answers to all those questions, I can move forward. So I usually will produce a pretty long list of questions, but it's a comprehensive list, and then I shouldn't have to go back to the client much more after. If this video was useful and you want to learn more about how to use R for your client's data analysis needs, please subscribe.